To mention that on each of the handouts for the lectures, I have the corresponding reading material listed on the handout, and I've listed it as section numbers in the chapters rather than page numbers, so that's a little bit of a difference. And the reason why I've done that is that we've had many different versions of the book in this class, and they don't seem to change the section titles or the section numbers, but they do change the page numbers associated with them. So if I give you section numbers, then you should be able to use whichever version of the book is available to you. So that's how I have it listed now, and the reading assignment is also listed on each problem set as well. So when you're going over the handouts later studying for the exam, you can see where in the book this particular lecture, the material is, so you can go and do that reading. All right, so we talked at the end of the class last time about Le Chatelier's principle, and this is a principle that you can use to predict the direction of change of a reaction, whether it'll shift to the right or shift to the left. And simply stated that systems tend to respond in such a way to minimize the stress. So if something is added to the reaction will shift in a way to minimize that stress caused by the thing that's added to the system. So we talked about adding reagents and removing products last time, and now we're going to go on and talk about what happens when you change the volume. So if you have a system at equilibrium and you change the volume of it, and here in particular we're talking about a gaseous system, what's going to happen? So what do we know about volumes when it comes to gases? We say that a decrease in volume of a gaseous system causes an increase in total pressure. What equation leaps to your mind when I say those words? Exactly, PV equals nRT. Yes. So there's a relationship between pressure and volume. N is the number of moles, R is our gas constant, and T is our temperature. This is one of the things that usually sticks from high school, and if you haven't seen it before, it's pretty easy to get up to speed with this equation. So Le Chatelier's principle then predicts that the system will respond, if possible, in a way to reduce the total pressure. So if you decrease the volume and you cause an increase in total pressure, Le Chatelier says, wait a minute, the system wants to respond to minimize that stress so that it's going to respond in such a way to reduce that total pressure. So let's look at some examples of this. So we have an example of a reaction where we have 2 moles of P2 gas going to 1 mole of P4 gas. And I have a little cartoon here to show this. So we have our P4 gas up here and our P2 gas. All right, so what's going to happen if we're going to change the volume of this system? So if we're going to decrease the volume of the system, then the reaction should shift toward products. So let's think about that. So here in the middle, we have, switch pointers. Here in the middle, we have our sort of system. And then on one side, what happens when you decrease the volume. And on the other side, we're expanding the volume. So first, let's consider our system when we're going to compress that volume, decrease that volume. So what would be true is that the system is going to respond in such a way to minimize that stress that has been put forward by decreasing the volume, and you're going to try to compensate for that. And in this case, you can compensate by a shift toward products. Why is that? Well, it all has to do with the stoichiometry of this equation up here. So for every 2 moles of reactants, you get 1 mole of products. So if you shift from the 2 to the 1, that will cause a decrease in pressure, and so that will help compensate for the increase in pressure caused by the switch in volume. So you're going to respond in such a way to compensate for that stress. So a shift of the reaction to the right decreases the total pressure. So now let's think more about why